So let's start here. You don't need to write any of this down. We're going to do so a little later. But suppose you're given this following situation here. I'll let you read through that. The question is, what could you do to help visualize the relationship between R and V? Hopefully the conclusion you came to is that sketching a graph of the function is going to really solidify the understanding of the relationship between R and V. Here you might be able to think about how they're related, but when you actually sketch the graph, it's going to make life a lot easier. And then once you have that sketch, it will also make it much easier for you to answer some questions. So let's go ahead and add this to our notes now about how we can use radical functions to answer some real-life situational questions. So this is just sort of the key points that I've pulled out from 4.03. And what I want you to add to the beginning is that you should graph the function. Right? That's going to be vital to your understanding of the problem. Even when we start looking at some other methods for solving, the graph is still going to be something that you want to go back to. And to review, it's really important that once you have the graph of the function, your inputs and your outputs are clearly labeled, your x and your y-axis, with units. That you know what the information you're already given means. You might need to translate it into something that makes sense to you. And that you've figured out what it is you're trying to find. That's going to be crucial. And once you have those, you can use the information from the graph to make a conclusion, state your claim. One last thing to reiterate that's very important is that the rate of change of our radical functions are going to be decreasing over time. And what this means is that as we move farther on in our domain, the slope is going to get more and more shallow. And you can see this just by looking at the parent function. It's steeper nearer 0, and as I move towards positive infinity, it will become more shallow. All right, with that in mind, let's go ahead and take a look at the question that we just brought up in the discovery problem. So here's the situation. You'll want to pause right now and go ahead and copy this down, and we'll take a look at it briefly together and get some clear instructions about how we might solve this problem. So the formula, v equals the square root of 2.7r, is going to model the maximum safe speed, which is v, in miles per hour, at which a car can travel on a curved road. So you can imagine it's making this huge banked turn, maybe like it's in a Daytona 500 race, which actually just happened this past weekend, on a curved road with a curvature of r in feet. And we're going to answer a bunch of questions, but before we do so, we want to make a sketch of our function. So go back, if you need to 4.02 to remind yourself about how we're going to sketch this function. We'll find the domain, we'll find the range, and then you're going to pick 3 points to actually plot so that you get a real good, accurate sketch of the graph. So go ahead and do that now on your own. We'll take a look at the graph together, and then you can actually go answer these questions by yourself. Okay, so to make sure that you're on the right track, here's the setup for my axis. And let's talk a little bit about the domain and the range. Pretty clearly here, the domain are going to be all r values greater than or equal to 0, because anything less than 0 would give me a negative radicand. I can't take the square root of a negative number. And that, of course, means that I'm only going to be graphing my function from 0 onward. And that helps me think about the range, and since this has a positive coefficient out front, I know that my function is going to be increasing. So my range will be all values of v greater than or equal to 0. And then you can go ahead and pick a couple of points, pick 3, and I would space them out nicely along your graph. Use a calculator to compute them so that you get them nice and accurate. And then use the graph that you've sketched to answer parts B and C. We'll look at those together in class, so make sure you have a nice solution and a written out answer with justification explaining how you found those solutions.